do a little introduction to what's called a logarithmic equation. One of the things I want to just unpack real quick for you is in math, everything has an opposite. So like if we were going to compare opposites, if you had something like y equals x squared, the opposite of that would be y equals the square root of x. If you had something like if I said what's the opposite of multiplication, you would say division. If I say what's the opposite of addition, you would say subtraction. If I said what's the opposite of something like, let me think of another one, even y equals x to the third, y equals the cube root of x would be the opposite. So everything we do in math has a way to undo it. Okay, so we always can undo anything we do in math. That's what we're going to use with logarithms. This idea of this thing called logarithms, which you probably haven't ever heard to, and exponential equations, they are opposites. Okay, those are opposite operations, opposite things to do it. So if you had the equation y equals a to the x power, that's an exponential equation. That's an exponential equation. The logarithm equivalent to this, the logarithm equivalent to that using the same letters is log base a. Remember, I called that a the base when we were doing it and we were looking at those problems from the earlier in this unit of y is equal to x. And I'm actually going to change this letter. I'm just going to change it to a b. I'm going to make it a b because I want to make sure that you know that that's the base. This is the logarithm equation. So that's how you convert from a log to an exponent. You can go in either direction, and I'll do a couple of examples and I'll show you what I mean and what the actual examples represent. If it's written log and there's nothing down here, it's blank of x, this base is 10. Just so you know, it's just, and it's something that it'll make a little more sense as I do some of these problems, some of the examples. If you have log base e, which is e is a scientific number, it's a scientific growth number. That's another way of writing that. We write that in shorthand. This is called the natural log. Natural log is used a lot in sciences and in economics because of some of its properties of growth. But we don't need to know that. You just need to know what that natural log is. So let me do a couple of problems here. So if I were going to solve this for x, now, could I use photomath? Sure, I could use photomath, but it won't really help you, figure out how these things work. So try to resist using photomath. I have a scientific calculator up there on my screen, and I'll use that in conjunction with this. But let me zoom out a little bit, and let me look at this conversion. So if I'm going from a log equation to an exponential equation, and I put these parts in the right place, what I have, a way I could write this is 2 to the second power is equal to x. just look back up here on what I'm using. I'm going to use that idea. And I'm either going to go from the left log equation, from the right log equation to the exponential equation. So right now I'm working in this direction. Okay, I'm working in that direction, taking a log equation and turning it into an exponential equation. In this case, x must be 4, and that's what it is. Another way of thinking about this is this is 2 to the second power equals x. That's another way of thinking of how you would write that. So like if I were writing this one, this would be x to the second power equals 36 if I were to write it out in words. So the kind of idea is I go x to the second power equals 36. Well, what times itself equals 36? X must be 6 in that case, because 6 times 6 equals 36. So if I'm writing like this one, this is 4 to the x power equals 64. 4 to the x power equals 64. Now you may know what that is. You may know that that's 3. Okay? If you didn't know that was 3, one thing you could do is you could go over here and you could go, you could do 4 to the first, that equals 4. 4 to the second, that's 16. 4 to the third, that's 64. We could keep on going. 4 to the fourth. We know that we're looking at 64. So that's an important piece on how you read these things, and then if you write it out on how you read it, you'll probably be able to answer the question. I know Photomath will do these. It's just not going to help you when you have to do the problems. On something like this, write the log equation as an exponential equation. You don't need to solve for x. Again, we're just converting this. So this is, if I write this out in words, x minus 3 to the third equals 2x. So x minus 3 to the third is equal to 2x. I don't have to solve it, I'm just rewriting it. Rewriting this one. This is 8 to the third is equal to 4x. I know it says I don't need to solve this one, but I'm going to solve this one. So if I wrote this, 8 to the third power equals 4x. If I needed to solve this, let's just pretend I was going to solve it. I could do 8 to the third power and find out that's 512 equals 4x. So x is equal to 512 divided by 4. Now I actually can put this into this Desmos calculator. So one way I could do it is let me make sure. Actually, it's not going to let me do a different base for logs, so forget that idea. Anyway, that's how I could solve it. I could do 512 divided by 4 equals 128, so x equals 128. Okay, so that's how you could solve that. You didn't have to solve that on Delta Math. You could have stopped, right here was all you needed to do on Delta Math. I just wanted to show you that you could actually solve this one. The last one would have been a little bit harder to solve. That one was a little harder, more challenging to solve. So let's take this one. Now, Remember, this is the natural log. So this is the natural log. So another way of writing this would be log base e of 5 is equal to 2x. So this is e to the power 2x is equal to 5. So if we did this, e to the 2x is equal to 5. Converting back and forth is an important piece. This is something that I know that they put on an ACT or an SAT all the time. Just as a side note, if I wanted to solve this, let's say I wanted to solve this, okay? If I wanted to solve the natural log of 5 is equal to 2x, we could actually do that on this calculator over here. We could say x is equal to the natural log of 5 divided by 2. If you look over here, see how in the main thing I don't have it, but if I hit this functions, there's a natural log key. So if I did the natural log of 5, and then I closed the parenthesis, and I did divided by 2, I would get, in this case, x is equal to 0.8480447. Now, you didn't have to do that for Delta Math. On this particular problem, this is all Delta Math is asking you to do. It's a pretty easy assignment today. I plan on putting more in, but I decided, you know what, I'll stop right there. Okay, so we'll talk about what the graphs of these look like tomorrow and how you can interpret the graphs of these and then where this plays in. But we're going to try to stop right there and see if you can answer the questions that they have for you. Good luck. Let me know if you have any questions. Now Murphy's going to make fun of me because I'm trying to stop my video, but it takes a long time, it seems to me, to stop this video. So